बिस्मिल्लाहिर्रहमानिर्रहीम। उम्मीद है कि आप सब लोग खैरियत से होंगे। अल्लाह तबारक ताला से दुआ करूँ कि अल्लाह तबारक ताला आपको खैरियत से रखे। जैसा कि आपको मालूम है कि हायर एजुकेशन डिपार्टमेंट गवर्नमेंट ऑफ पंजाब ने ऑनलाइन क्लासेस का जो है सिलसिला शुरू किया है। इसी सिलसिले में जो है पहला जो है वो लेसन, उस टाइटल आपका है मैकेनिक्स 2 और सेमेस्टर है सेकंड। उसके में जो टॉपिक है वो न्यूटन लॉ ऑफ यूनिवर्सल ग्रेविटेशन है और ग्रेविटेशनल इफेक्ट ऑफ स्फेरिकल डिस्ट्रीब्यूशन ऑफ मैटर है। और इसके साथ एक बात आपको जहन नशीन रखनी पड़ेगी कि हो सकता है कि इन्हीं लेक्चर्स की बुनियाद पे जब कॉलेजेस खुलें तो आपका एग्ज़ाम हो, तो लिहाजा इन लेक्चर्स को गौर से सुनना है। और अगर कोई इसके लेक्चर के एंड पे कोई क्वेश्चंस आपके जहन में आते हैं तो आप जो हमारा व्हाट्सएप ग्रुप है उसमें आप डिस्कस कर सकते हैं। तो इसके साथ ही जो है वो हम शुरू करते हैं पहला आपका लेक्चर। बिस्मिल्लाहिर्रहमानिर्रहीम। न्यूटन लॉज ऑफ यूनिवर्सल ग्रेविटेशन। न्यूटन ने जो सबसे पहले आइडिया दिया था ग्रेविटेशन का वो ये था कि वन डे ही वाज सिटिंग अंडर अ ट्री एंड इक्वल फॉल ऑन इट एंड ही यूजेस दैट द प्रॉपर्टी ऑफ ग्रेविटेशन टू द मोशन ऑफ अर्थ and heavenly bodies, and he compute the acceleration of the moon towards the earth from the period of evolution and the radius of orbit around the free acceleration. Also Kepler's laws, from Kepler's laws Newton tried to account for the difference in between two acceleration, one acceleration due to earth and second one is the acceleration due to the moon. So if we have some comparison between the acceleration due to gravity on earth and acceleration due to gravity on moon, we have to study about the Newton concept of gravity. Newton says that gravity is a phenomena where things with masses are brought towards each other. Newton described gravity as a force. So Newton's gravity has been superseded by general relativity, and it is still in use because it is simpler and gives sufficiently accurate results for more of its applications. So that was the natural incident as you told about. The man who was under the tree and falls on it, and he concluded that this is the natural phenomena which lead the next law, which is Newton's law of gravitation and gravitational acceleration. So we'll study these things related to different bodies such as moon, and you know it, the gravity due to the earth is denoted by G capital small and subscript E, GE. Gravity on earth is equal to the 1 by 6 times gravity on moon, and its value is round about 0.0027 divided by 9.8, and round about becomes 6.7 meter per second scale. So if we have a value of G on earth and it falls on it, and the earth has a radius of RE, then this is the same, the acceleration A with which earth towards acceleration A is equal to G with which earth attracts a body towards its center. It is known as its weight, and same acceleration due to the moon is denoted by AM. So the moon's gravitational field causes the earth to accelerate towards the moon. So we have first of all give the definition of Newton's law of gravitation. And Newton's law of gravitation says that everything in the universe attracts everything else in the universe. The more massive objects, the stronger the force of attraction is. And in the sense of mathematically, we have another definition. The force of attraction is directly proportional to the product of masses and inversely proportional to the square of the distance between these masses. And we have these two equations. When they combine, we have F is directly proportional to the m1 m2 over r square. And when this sign of proportionality is gone, and we have to take a proportionality constant. Here we have capital G, which G is known as gravitational constant. And then we have a mathematical relation for F. F is equal to G m1 m2 over r square, and dimension of G is given by, we know it from the equation F is equal to G m1 m2 over r square. Therefore G is equal to F r square m1 m2. F has dimensions of m1 l1 t minus 2, and r has m0 l1 t0 whole square, and m1 l0 t0 is the dimension of m1, and same dimensions for m2, m1 l0 l t0. And by simplifying these, we will get the value of dimension of G is m minus 1 l squared t minus 1. Here we have m0 quantity just like m0 t0. What does it mean? It means, you know it, when we have a power of 0 of anything, it is equivalent to 1. So we have all these other equations and the quantities which are all have m, l and t in the form of m, l and t. So we have r is the, you know it, distance, and distance is measured in meter, and meter had dimension of l. So we have m naught l t naught mean 1. So by simplifying these, we have m1 l cube t minus 2. So by getting an idea about these things, we now discuss Newton's conclusion from it. Some says that the attraction is always present in the bodies. For example, everything in the universe attracts each other, but for example, buildings, walls attract each other, but the attraction is so weak that we can't have the idea. So also attraction between objects around us have a force of attraction between them. Similarly, on the scale of solar system and the interaction stars or galaxies, gravitation is followed by them for domination as a dominator force. So again we can repeat the definition. Every particle in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Mathematically, you will have again F is equal to G m1 over m2 r square, and have a dimension of, earlier we have derived it, L cube t m minus 1 t minus 2. So in the vector form, keeping in mind the gravitational law obeys Newton's third law of motion, and gravitational force is independent of the presence of two bodies independent of the medium present in two bodies. So if we have two bodies M1 and M2, let we have position vector R1 R2 is represented by with respect to M1 M2. Then we have a force which M2 exert on M1 is F21, and similarly when we have a source point M2, then M1 attracts M2 with a force denoted by F12, and the position vector is changed from R12 to R21. So the force exerted by M1 on M2 with position vector directed from source towards field point, and the force exerted by M2 on M1 with position vector directed from source towards field point. So we have again the proof of third Newton law of motion, and keeping in your mind, if we have a force exerted on M1 towards M2 and M2 towards M1, the force F is weaker if the distance R is farther, and if R is increased 2 times, then the force becomes 4 times smaller. Keep in your mind, again I am repeating it, the force is weaker if the distance R is farther. Mean if we take R as 2 times, then the force becomes 4 times smaller. So gravity is not only the force, more than one force can affect another object. So object is accelerated according to the sum of forces affecting it. And we have the same again, R is the distance, F is equal to capital G M1 M2 over R square. This is the mathematical form of the Newton gravitation law. So we have mathematical form, which again we have this in the vector form. In the vector form, if we again say that force exerted by M1 or M2 with position vector directed towards field point, and B is the exerted force by M2 on M1, we have F21 is equal to minus G M1 M2 over R1 square into R12, and we have again F12 mean minus G M1 M2 over R21 square R21 cap. So as R12 and R21 are in the opposite direction, so we have R12 is equal to minus R21. So we can write it here as F12 is equal to minus 2 F21, but the magnitude of the forces F12 and F21 will be equal. So F12 magnitude is equal to mod minus F21 mod is equal to G M1 M2 over R square. So in this way we say that the gravitation law will be Newton's third law of motion. So for the calculation of value of gravitation constant G, we say that the pointing along the line joining their centers in opposite direction, the value of G experimentally was determined by Cavendish, and its value is 6.67 into 10 raised power minus 11 Newton meter square per kg square, with the uncertainty 0.013% plus negative 0.013%, mean it can have a value less or equal to 0.013%. So the value becomes as negative 0.00085 into 10 raised minus 11 Newton meter square per kg square. See from different angle, Newton law of gravitation, you know it. This is the, let us suppose we have a mass M and this is the earth, and in between these two we have a distance r. We say that the force between two is strong force of attraction. When we have a mass m here, the distance is increased, so the force will be decreased, so there will be a weaker attraction and weaker force will be observed. The gravitational attraction, a force Fg, depends on r. So we say that gravitation force depends on r, as it is inversely proportional to the square of the distance between them. It can be denoted by small r, it can be denoted by capital R, it does not matter. So if we have m is located at different places, we can have m2 distance r, m stronger force, m1 is r weaker force. Does Fg depend upon mass? Mass of, you can have mass of earth, because in the formula we have m by r square. So Fg जो ग्रेविटेशन फोर्स है वो डिपेंड करती है mass पर. So we prove that Fg depends upon the mass. The second topic today, our lecture is about the gravitational effect of spherical distribution of matter. Let us suppose we have a spherical shell of having mass denoted by capital M with its thickness small t as compared to its radius small r. So we have to calculate the value of gravitational force on an external particle m having mass small m and distance r from its center. We also assume that each particle of the shell exert a force on point MP that is proportional to its mass and inversely proportional to the square of the distance between the particle of the shell under consideration and P, and always directed towards the line joining them. So when if resultant force on P will be resulted or calculated to all of the spherical shell, we have to draw cosines with O as vertex and OA as axis and semi-vertical angles theta and d plus theta d, or theta plus d theta. So these cones cut off from the shell as a ring of angular width d theta or linear width r d theta and radius r d theta. So the circumference of the ring is 2 pi r sin theta as shown the diagram. So we have a diagram. This is the center O, this is the point P around which we have to take this value of, and this is the strip having r d theta linear width and thickness t. This is the thickness t, this is the r radius, and this is the small x value from this to point this, and this is the same, and this is the df, and from the volume of the circumference, length cross linear width cross length thickness. Length we have here is equal to the circumference of this, it is equal to 2 pi r sin theta, linear width is r d theta and thickness is d. So we have value of df. To calculate value of df, we have to, first of all we have to calculate the volume of the strip. We know that the density is equal to mass per unit volume, and when we have a strip, then the density is given by mass per unit volume, and volume will be equal to mass density is equal to mass per unit volume, and volume will be equal to mass over density. So we have dV in this way, 2 pi r sin theta into r d theta cross t. So by simplifying we get 2 pi t r square sin theta d theta. If we have rho, the uniform volume mass density of the material of the shell, then again we have the formula rho is equal to dm by dv, and dm will be equal to rho into dv. By multiplication we have, putting the values from the above, we have rho into 2 pi t r square sin theta into d theta. It is multiplied by rho this way. Similarly, we have every particle in the ring, each of mass dm is at the same distance x from the point P, so it will attract the mass m at point P with a force of magnitude df dash. So df dash is equal to capital G m dm over x square. This is the mass, this is also dm, smaller mass of the ring, this is the x distance from the point P. So we have the axial component of this force is given by df, axial mean x component, you know it, the x component of anything is given by, suppose we have vector a, then ax is equal to a cos of theta. So we have axial component of df is equal to df dash cos of alpha. So putting the value of it from equation 3, we have gm dm over x square cos of alpha. This is the value of vertical component of forces of attraction of the opposite particles cancel in each pair and axial components add up. So we have now calculate the total gravitational force due to the entire shell on particle P by interacting equations 10.4 within the appropriate limit. We have df is equal to 2 pi gt rho m r square sin theta d theta over x square cos of alpha. From the geometry of the diagram, you know it, cos theta is equal to base or hypotenuse. This is the base r minus r sin theta, and this is the hypotenuse r. So separating these two, r by x minus r cos theta by x. Similarly, again from the cosine's theorem, we have x square is equal to r square plus x square minus 2r cos of theta. So here we have, do simplifying again, take this term on this side and x square on this side. We have 2r cos theta is equal to r square plus r square, capital R square minus x square. So these two, this term 2 coefficient 2r again in the next step becomes here denominator for this term. So we have r cos theta is equal to r square plus r square minus x square over 2r. Then again differentiate with respect to x. We have r sin theta d theta, cos theta has value of differentiating sin theta d theta, x by r. This is the r square. When we differentiate with respect to x, it has a value 0. Capital R square with respect to x has a value of 0, and this one is minus 2x dx minus 2x dx over 2r. r is cancelled, and we have x by r dx. So we have the next one, sin theta d theta is equal to x dx. Simplify again for the value of g. We have sin theta d theta is equal to x d theta over r theta. Again combining equations 6 and 7, we have cos alpha is equal to r by x minus x square r square plus x square minus x square over 2rx. So using equation 8 and 9 in the equation number 5, we get df is equal to 2 pi gt rho m r square dot x dx r capital R x square into r by x minus, this is the value of cos of alpha, r square plus r square minus x square to r x. Then again we have denominator, taking LCM, we have this one 2r is in the denominator, and again we have, by simplifying, we get df is equal to pi gt and m capital R over r small r square is into r square minus r square over x square plus 1 into dx. So in this way again we have to take the integration, we have to take integration within limits as the shell has a value of x starting from r minus capital R plus small r plus capital R. So we have, this is the value constant pi gt rho m over r square r. So we have to take integration starting from r minus r to r plus r into r square minus r square x square plus 1 into dx. So by simplifying again and getting, we have r plus r, r minus r in the equation, we can have the value of g 4 pi r square tm by m r square, and f is equal to capital G capital M small m over r square, where we have to take capital M as 4 pi r square t rho, the total mass of the shell. So in this way we have a result for the different values of small g, and when we take the value of small g, we proved here that the uniform dense spherical shell attracts an external point mass as if all the mass of the shell were concentrated at its center. So the same conclusion we shall draw for a solid sphere and can be generalized for the Earth and Moon and the Sun if they are assumed to be perfect spheres of uniform mass volume density. Keep in your mind, we can take it for Sun, Moon and Earth. What we have to take granted that these all have to be taken as perfect spheres of uniform volume mass density. So if we have a point P lies inside the spherical shell, we can integrate equation number 10 between limits r minus r and r plus r, so that we have the value of f by taking these value from r minus r to r plus r, we get is equal to 0. So we have another result from this. That result is a uniform shell of matter exert no gravitational force on a particle is located inside it or the interior of the spherical shell is a field free region. This results explain the decrease in the value of g with depth below the surface of the earth becoming 0 at its center. So we have a value of g at the center of earth is 0. So this is very important result, as keep in your mind, as we go from the surface of the earth, above the surface of earth, as we lead towards the higher point, the value of g is decreasing, always decreases. And if we dig a hole in the earth and we go towards the center, as we go towards the center, the value of g is also decreases. So in the both cases, when we go up from the surface of the earth or go down from the surface of earth, the value of g is 0. And when we reach at the center of the earth, this value becomes 0. Thanks for the listening the lecture, and now enjoy some solved problems which can have some mental stress too. Number 1 is find the value of force when two masses of 75,000 grams each are separated by a distance of 5 centimeter. You know the value of formula to find the value of gravitational force. F is equal to G small m m2 over r square. Capital G has a value of 6.67 raised power minus 11, and this 75,000 each mass is converted into kg and will become 75, and this 5 cm is converted into meter. This is distance of 5 centimeter. No, it is 50 centimeter. Clear? When we divide this on 100, this will become 0.5. Here we have 0.5. So the distance of the separated by a distance of 0.5 cm, not 5 cm. So we will have this value becomes 1.5 into 10 raised power minus 6 Newton. Again we have find the value of m1 when m2 of mass 25 kg are placed at a distance of 1.2 meter apart from it, attracting each other by a force of 2 into 10 raised power minus 8 Newton. So we have the same formula, capital F is equal to capital G m1 m2 over r square. So to find the value of m1, we change the order of the equation. So m1 will become capital F r square over G capital G over m2. Putting these values and by simplifying we get m1 is equal to 17.27 kg. Good luck. This is the again a problem in which we have a gravitational force of attraction between two elephants, one of mass 1 into 10 raised power 3 kg and the other is mass 8 into 10 raised power 2 kg when they are separated by 5 meter. So we have these data of the concerned problem is m1 m2 r, capital G has a value, and F formula of gravitational force is capital G m1 m2 over r square. Putting these values you have to get, you will get Fg is equal to 2.1 into 10 raised power minus 7 Newton. So again we have a very important part of our lecture, which in the final exam will be 20% of the total marks. So we have to open our ears to get the solution and to have the MCQ section. The value, first of all, the first question is the value of G on moon is dash times the value of G on earth. The answer is 1 over 6 times. Second is the value of G at the center of earth is, the answer is, you should conclude it at the end. I will give you the answers. Capital G has dash value for all of pair of particles. A is same, B is 0, C not same, D none of all. Fourth one is capital G and small g are of nature. Number 1, capital G is scalar, small g is a vector. Second, B answer is both. First capital G is vectors, second one is scalar. Then C is both scalars, D is both of a nature of vectors. Fifth one is Newton's law of gravitation obeys Newton's law of motion. Third law, second, and first or last one is all A, B, C. Formula to find the total mass of the spherical shell is 4 pi r square t rho. Second one is 4 pi r square rho. Third one is 4 pi r square t rho. D is 4 pi r square t. Seventh one is interior of spherical shell is a field dash region. Number 1 free, B 0, C null, and D is all A, B, C. Eighth one is value of G is 0 with depth. Number 1, it is the value of G is dash with depth. 0 is not here. It decreases, increases, same, or none of all. D is none of all. Ninth is sun-centered scheme was proposed by Copernicus, Newton, Ptolemaic, and the fourth is 10th is laws of planetary motion were introduced by Kepler, Newton, Ptolemaic, and the answers for all these are A. The option A is the answer of all MCQs. It means all MCQs have a answer A. So you should have some second one short questions. Second, these short questions always come in your annual exam as a part of the annual paper. So you should prepare these short questions. Number 1 is define Newton's law of gravitation, also give its mathematical form with diagram. Second one is illustrate the value of small g at number 1 earth, number 2 height h above surface of earth, third one is at the center of earth. Third one is compare gravitational force with Coulomb's force. Number 4 question is can you determine the mass of moon? If you can, what you need to know. Fifth one is 2.4. This is the numerical and very interesting numerical. If you have some idea about all this lecture, what you have taken from this lecture, you can solve easily. By easily you can solve, the answer is at the end of the question, but solve it. 2 masses repel each other with a force of 100 Newton. One of the mass is increased by 10% and the other is reduced by 10%. Find the new force of repulsion at the same distance r. So in this way we have